we start? Okay, today we are going to discuss induction machine. Okay, so in that induction machine, we are going to see working. Okay, then the basic principles behind this. Right. So mainly we are going to focus today working and principles. Okay. So we know that induction machine is nothing but it is a rotating transformer. You know. So before that, what is transformer? You know, transformer is a static device which transforms the supply energy. Okay, from one winding to another winding without changing frequency and power. So changing frequency and power. Okay. So how it is transformed? First of all, you need to understand how the transformer is working. Then only you can be able to understand the induction machine. Right. So transformer, you know that we are giving supply. Okay. What will happen whenever we will give AC supply? We are talking about AC supply. Okay. So transformer will work with AC only. Right. Whenever I am giving supply, AC supply, some frequency, for example 50 Hz. Okay. So whenever I am applying AC supply, what will happen? The current will flow in the circuit. Okay. Right. So whenever the current is flowing through the winding, what will happen? Due to the flow of current, the flux is generated in this coil. Okay, coil or conductor. Okay, right. Whenever the flux is generated, okay, you know that the flux, that is nothing but magnetic flux lines. It always flow from north pole to south pole. Yes, north pole to south pole. Okay, like this, flux will flow from north to south. For example, here there is no pole at all. Then what will happen? For example, this is our winding. Okay, so I am giving supply. Right. So now, whenever the current is flowing, what will happen? The current, due to the current, the flux is produced. The flux will flow from core, that is the coil to air, and again bring back to the coil. Okay, so it is going away and bring back to the coil. So we know that. So always flux will leave from core and enter to the core. This leaving place we call it as north pole, and entering place we call it as south pole. So finally, what I conclude, whenever the flux is flow from core to air, that is nothing but north pole, and air to core, that is south pole. Okay, right. In transformer, what we are doing, we are providing a path for the flux line, so it is nothing but core. Okay, right. So what it is doing? So it is provide a path, flux path. Okay, right. It is flowing, flux is flowing here. Yeah. Right. We are providing a path, so the flux is flowing. Okay. So whenever initially I am giving current is flowing. Due to the current, flux produced, the flux will flow north to south via the core. Okay, right. So this is not a constant flux. This is what flux? Alternating flux. Okay, why? We are giving alternating current. So the flux also alternating. So what is alternating? What is alternating? It alternates plus and minus 1. Okay. For example, this is 5 plus 5, then this is minus 1. So the current is plus 1, it going rise and coming 0, then again it is going negative, coming 0, positive, like that it alternates the direction and magnitude lines. Okay, right. So because of this current, our getting flux also alternating flux. Oh, right. Whenever an alternating flux is cutting or touching the one coil, okay, like this coil, okay, due to the change in flux, the EMF is induced in this conductor. Okay. So how many conductors there? For all conductor having that EMF. Okay. So EMF. Okay, here one EMF, here. Okay. How many turns is there? In every turns we have EMF. If the load is connected, then what will happen? The current flow will be half. Okay. The current will flow. It is half. Due to the current flow, I have already explained here in the primary side. Due to the current flow, flux will develop, right? But here what happened? Due to the change in flux, EMF is generated. Due to EMF, when current is flowing, due to the current, what happened? Again, the flux is produced. Okay, you may have the question, sir, if I give DC supply, what will happen? Nothing. If you are giving DC supply, that is constant flux, right? So if you are giving DC, then it will produce constant flux. Yes, it is produced flux, that is nothing but constant flux. So it is constant flux. The constant flux never do anything. Okay. So as per our Gauss's law of electromagnetic induction, whenever the flux produced in the coil, okay, it must be a change. Whenever the changing flux is there, then only we have a induced EMF in this coil. Okay, right. Due to that, EMF is produced and current is flowing, then what will happen? Due to that, another flux is produced. Okay, that flux we call it as phi. Okay, so this flux we call it as phi1. So finally, this flux is opposing that one main flux. Then finally, we will get resultant flux. Okay, so this is a basic concept of transformer. Okay, if the number of turns are increased in the secondary side, the voltage will increase, that is EMF is increased, we call it as step up. If it is reduced, step up. Okay, so remember this concept, we are going to apply the same electromagnetic induction principle in our induction. Okay, shall I have this? Right, now comes to induction. So by the name itself we know that it is nothing but induction. It's what on the principle of induction, right? So see, so I will give you some little example. See, you think that we are dealing with three-phase induction motor. We are going to explain. Okay, we are going to know three-phase induction motor how it is. Okay, so see here we have one winding at space apart 120, an angle 120 like that. Okay, here one coil, here one coil. We call it as this is nothing but stator. Okay, right. So in rotor we have a rotor also. In this rotor we have another coil. Here also coil is there. Okay, here also coil is there, but we need to study after that, so that I am doing this. So this is R Y B. Okay, R Y B. I am giving supply to the coil. Okay. So this coil is the first one connected here and another one connected here. For this here, for this here. Okay. See. So now this is R, then this is R dash, this is Y, this is B dash, Y. Okay, so it is going on. First of all, you explain the concept, you are thinking like that. Don't worry, now we are going to explain. See, so whenever I am giving supply, what will happen? Immediately, okay? Immediately what will happen? Current will flow, then due to the current, flux is produced, right? What flux that is? What flux that is? Alternating flux. Why? Because we are giving AC supply. Okay. So for that, for I have some amplitude, certain period, and also see this one. Think like that. So this is R, Y, B. Okay. See, at certain period R is maximum. At certain time period R is maximum. At certain Y is maximum. Okay. Then B is maximum. Right. First R supply is going. Okay. R supply is going. That time what will happen here? Magnetic field is created, right? Initially here magnetic field is created. Then after some time what will happen? I am moving this here. After this is nothing but time. Okay. So then what happens? R is reduced. That R current is reduced, but B is increased, right? Whenever current is increased, what will happen? Magnetic field also, the strength is also increased. So now here reduce, here increase. Okay. Then B increase, then reduce. Cyclically, what will happen? Here maximum, here maximum, here maximum. Maximum, maximum, maximum. So what will happen? The maximum is rotating. The maximum value of current and magnetic field is rotating. So we call it as rotating magnetic field. That is nothing but rotating magnetic field. Okay. Now coming. So we have a rotating magnetic field on the state rod. Okay. Right. Now I am placing a rotor. The rotor having the coil. Rotor having coil. Okay. Right. So already we discussed the pole formation, right? Okay. So here, for example, here core is there. Okay. Here head. Okay. So before that, we need to know right hand thumb rule. What is right hand thumb rule? The right hand thumb rule says that the thumb indicated current direction, then folded finger indicates the flux direction. Okay. So we need to know flux direction. For example, this is current direction, downward direction. Okay. This is current direction. Then what is this? Flux direction. Okay. I am approximately right like this. Okay. Like this. Okay. Like this. Like this. Okay. So current is coming down, flux is going this direction. Then what will happen? Here the flux is flowing from core to air. Already we discussed, right? What is the pole? Core to air. What is the pole? That is north pole. Come here. Then air to core. See, air to core here. Air to core means what? That is what? South pole. So here north pole. I am telling you. Here north pole, south pole. Okay. Right, but this is connection is connected here also. Okay, so I am splitting like this. This is north, south. Okay, then here also. For example, this direction, this is direction of current is. So this direction is north pole. So we take it as this is north. This be right, south pole. Okay, then here north, north, south. Okay? Right. Now what will happen? Here poles are formed. Okay? Right. Here outermost area poles are there. North pole, south pole, everything is there. Okay. Now I am placing conductor as per Faraday's law of electromagnetic induction. What will happen? Whenever current flowing through a coil, okay, whenever current flowing through one coil, okay, because of that EMF is induced in the other coil, that is electromagnetic induction. Then Lorentz force equation, what I said, Lorentz force equation, whenever a conductor placed under a change in magnetic field, then what will happen? The conductor experiences the force. The conductor experiences the force. So already we created the change in magnetic field. It is rotating magnetic field in the outermost area. Then I am placing a conductor as per the Lorentz force equation. The conductor is experiencing. Okay. This as per this Lorentz force equation. Another also we can employ. Whenever the pole here north pole is there, okay. So because of that, here flux is there. Pole means what? Flux. Then what will happen here also? Magnetic flux will create. How? Because of the flux is linked to the conductor. Due to the change in flux, current will flow. Due to the current, again the flux is generated. Okay, right. So if here also flux, due to the flux, poles are formed. For example, see here, north pole, south pole. Assume that. So what is this? Both poles are same pole. Same pole. What will happen? Repel. See here. Here also same pole. Okay, here south pole. Then what will happen? Due to attraction and repulsion principle, the motor will start to rotate. This is the working principle of three-phase induction motor. Okay, as the name is mentioned, induction, because of the induction, it is rotated. What is the time now? Shall I conclude? Right. So, induction machine working under the principle of electromagnetic induction. Because of the pole, outermost area of pole is there, that is the rotating magnetic field is there. Due to the rotating magnetic field, whenever placing a conductor in the magnetic field, okay, the conductor experiences force. Okay. Thank you very much. We will see next video, an interesting video. Okay. Thank you. Bye.